We're now going to solve radical equations. And again, a key thing here is to look for extraneous solutions. And remember that these occur because the square root of a number is always the positive principal root when you're dealing with square roots. And so it's possible that when you square both sides of an equation, which is something that you're going to need to do, you might create an answer that doesn't work because of the principal square root. So let's start with x equals the square root of 6x minus x cubed. So the first thing we're going to do is we're going to square both sides. This gives us x squared equals 6x minus x cubed. And since this is a negative x cubed is our highest degree, I'm going to move that because I always like them positive. And so that's going to give me the equation x cubed plus x squared minus 6x equals 0. Start by factoring, pull out an x, that's x squared plus x minus 6 equals 0. Factors of negative 6 add up to 3 are positive 3 and negative 2. This gives me as my answers x equals 0, x equals negative 3, and x equals 2. Now it's absolutely vital that we check our answers on this one. So we're going to plug them all back in, and the first one's easy. 0 equals the square root of 0 minus 0. 0 equals the square root of 0. 0 equals 0. That's true, so this answer works. The negative 3, though, we're going to get negative 3 equals the square root of 6 times negative 3 minus a negative 3 cubed, which gives us negative 3 equals the square root of minus 18 minus a minus 27, which is plus 27, and minus 18 plus 27 is the square root of 9. Negative 3 equals 3, which is false, so that answer doesn't work. And 2 equals the square root of 6 times 2 minus 2 cubed is 2 equals the square root of 12 minus 8. 2 equals the square root of 4, and 2 equals 2, which sure enough works. So my answers to this equation is simply x equals 0 and 2. The minus 3 got ruled out because it doesn't actually work when we plug it back in. Let's show another example. Suppose I have the square root of 6x plus 4 plus 2 equals x. Well, whenever you have only one radical, you always want to get that radical by itself, so we'll subtract 2. And we square both sides, so that's a plus 4. And when we square both sides, we get 6x plus 4 equals x minus 2 squared is x squared minus 4x plus 4. That's that perfect square trinomial formula. So we'll subtract 6x and subtract 4. This gives me 0 equals x squared minus 10x. Factor out an x. And we get x equals 0 and x equals 10. So when we plug these in, let's start with the 0. The square root of 6 times 0 plus 4 plus 2 equals 0. Well, that's the square root of 4 plus 2 equals 0, or 2 plus 2 equals 0, which is false. So that one gets ruled out because 2 plus 2 is not equal to 0. On the 10, we get 6 times 10 plus 4 plus 2 equals 10 is 60 plus 4 plus 2 equals 10. Square root of 64 plus 2. Square root of 64 is 8. 8 plus 2 is 10. 10 equals 10 on both sides. So this answer sure enough works, and our answer is just the equation x equals 10. Now I know we're pushing time, but I want to show one more example. Suppose we have multiple radicals and an extra number. Well, here, always separate them out and always move the nicer of the one. So let's subtract the square root of x. So we leave the uglier one all by itself on this side. So x minus 5, square root of x minus 5 equals 5 minus the square root of x. And again, to get rid of the square root, we square. If it was a cube root, we'd cube. This I'm actually going to do out. It's 5 squared minus 2 times the first times the second plus the second squared. And remember, I'm using that perfect square trinomial a minus b squared is a squared minus 2ab plus b squared. So that's my 2ab. So x minus 5 equals 25 minus 10 square roots of x plus x. Let's get this guy by himself again. So let's subtract an x and subtract 25. That gives me minus 30 equals minus 10 root x. Divide both sides by negative 10. And we get 3 equals the square root of x. Well, let's square both sides. That gives me 9 equals x, or x equals 9. So let's try it. Let's plug 9 in and see what we get. So we get square root of 9 minus 5 plus the square root of 9 equals 5. Well, 9 minus 5 is 4. Square root of 4 is 2. Square root of 9 is 3. And sure enough, 2 plus 3 is 5. And so by squaring and by carefully isolating our radicals, we're able to solve radical equations.